Alright, so for my research project, I did Unit 5, which is Bonding and IMF. So first, what are intramolecular forces slash bonding? So intramolecular forces are forces that are within the molecule and they are in the bond. They can either be polar or nonpolar. So the three intramolecular forces are covalent, metallic, and ionic. Ionic is between a metal and a nonmetal. Covalent is between two nonmetals, and a metallic bond is like an element like iron or gold. So what is intermolecular forces? Intermolecular forces are forces which mediate the interaction between molecules, including forces of attraction or repulsion, which act between molecules and other types of neighboring particles, such as atoms or ions. The three types of intermolecular forces are hydrogen bonds, dipole-dipole, or London dispersion forces. Those last two are known as van der Waals forces. Hydrogen bond is the strongest out of them. Dipole-dipole is the second strongest, and London dispersion forces are the weakest out of these. Electronegativity. So what this is this is the measure of the tendency of an atom that attracts a bonding pair of electrons. So what the trend is as you go up the column, starting at francium, as you go up to hydrogen, it will start to increase. And as you go from hydrogen to helium, it will also increase. So it has a positive trend. So the weakest one is francium at 0.79, while fluorine is the highest at 3.98. So for my job, I chose pharmaceuticals. So pharmaceuticals this is an industry that discovers, they develop, produce, and they market drugs or pharmaceutical drugs for medication that can be administered to patients. And the purpose of this is to cure them, to vaccinate them, or to get rid of symptoms. So how is pharmaceuticals related to bonding and IMF? So one of them is they have hydrogen bonds. So in many pharmaceutical compounds, they have a lot of hydrogen bonds. So the purpose of hydrogen bonds, it gives them strength, it gives them a unique architecture, so it goes and makes them different, and it gives them a different purpose. And then scientists have specially designed these points so there are multiple hydrogen bonding points to give it strength and a unique architecture for them. So in pharmaceuticals, there's just not always one type that you find in the environment. So they're bonded together. So a few of them that are used in medicines is a benzyl group bond and adenosine. So a benzyl group bond is a benzene ring that's attached to a CH2 group. So these are a few examples of a benzyl group bond. And adenosine is adenine attached to a ribosugar molecule. So as you see, here's another picture of an adenosine bond. And IMF in pharmaceuticals. So what this is intermolecular forces play a pretty big role in there. So London forces and dispersion forces impacts how drugs spread throughout your body. And some enzymes are more potent than the others. So some enzymes may be able to spread more quickly and it's at a greater potency than other enzymes. And these two forces go in determine what is the result as it spreads through your body. But intermolecular forces are also used in adhesive, and they use adhesive so they can put a patch on you. And one example of this is a nicotine patch. So it goes and allows the nicotine to go into your bloodstream, but the adhesion keeps it on your skin, so it can properly go in. And here are just a few facts that I learned about pharmaceuticals over my research. So pharmaceuticals generate over $300 billion of profit a year, and this is just one company. Pharmaceuticals were invented in the 18th century, and this is when types of medicine and knowledge of disease began to form. Um, a lot of medicines are made up of simple organic materials found throughout the world, like willow bark, which makes aspirin. Penicillin is the first antibiotic that was used by doctors in 1928. And developing a new type of drug costs an average of $2.6 billion. Thank you.